Everyone, I'm a programming instructor here at Geek Education. In this video, we'll be going over important information about the free response section of the exam and 2 questions from a sample AP Computer Science exam. I'll be going over the best ways to approach and answer these types of questions and give you tips to help you ace your exam. If you haven't already, open up the sample questions we'll be going through in this video that are linked on this page. Now pause the video and I want you to try reading through and answering the questions by yourself first. So go ahead and pause, and I'll see you back here. Great, I hope you got a chance to try the questions yourself. Now I'm going to go through some important information about the exam, and then I'll walk through how I would answer some of the sample questions. The free response section of the AP Computer Science exam is worth 50% of your total exam score. It consists of 4 questions, and it should take you about an hour and 30 minutes. This gives you about 22 minutes and a half for each question. The questions in this topic focus on methods and control structures, classes, arrays and array lists, and 2D arrays. So now that we know a little bit more about the exam, let's get into the questions. Okay, so let's get started. On the screen here, you see the introduction to the free response section of the exam. We're going to go over some of the notes here. The first one says, assume that the classes in the quick reference have been imported where needed. So the quick reference is a handy little sheet that gives you some information about some of the classes you've learned in this course, the methods inside them, and the constructors. It's a really handy sheet to refer to during the exam, and it's a good idea to go through this so you know what's on it while you're studying and prior to actually taking the exam. It also says that unless otherwise noted in the question, assume that parameters and method calls are not null and that methods are only called when their preconditions are satisfied. We'll go over more what preconditions mean later in the video, but not null parameters just means that when you have a method call, the parameters that are passed into the method will not be null and they'll actually have a value. The last note says that in writing solutions for each question, you may use any of the accessible methods that are listed in classes defined in that question. Writing significant amounts of code that can be replaced by a call to one of these methods will not receive full credit. And all that means that is if you're implementing behavior that you've been given a method that does the exact same thing and you write code for it instead, you won't be getting the full marks. So instead, you should be making a call to that method that you already have. So it's a good idea to make sure you're checking what methods you have and that are available to you to implement your solutions. And again, we'll see that more in the actual questions. Okay, so now we've gone through the instructions, you know about the exam. Let's actually jump into the questions. Okay, so here's the first question we're going to be answering today. The first thing you want to do is a complete read-through of the entire question you're going to answer. When doing this, you want to take note of certain aspects of the question and the code you're given. You can also start thinking about how you might answer these questions. I'm going to read through the first question, and I want you to watch what I take note of as I read. So the description at the top says, this question uses a password checker to report whether a given password is weak, medium, or strong. So that's a good indication you'll probably be writing behavior that outputs either weak, medium, or strong given a certain input. The password checker class is shown below. You will write 2 methods of the password checker class. So we have our class declaration here. It's called password checker. And here we have our first method. It's a public method. It's also static. It returns an int. It's called numDigits. And it takes in a parameter called s that's of type string. We have our description of the method at the top. Returns the number of digits in s, so s is our parameter. And then we have a precondition. So this precondition says s contains at least 1 character. So a precondition is basically what we can assume to be true when this method is called. And the reason this is important is, let's say we were implementing this method. The precondition tells us that we can assume that we're going to have at least 1 character in s. And that means in our implementation, we don't have to actually check to see if it's empty first, and then in that case, handle it differently. We can just right away assume and know that s will always have at least 1 character. And that's really helpful for implementation. So that's why you should pay attention to preconditions. Now we're going to go through the next few methods a little bit faster. The next one is called numLetters, and it returns the number of letters in s. We have next numSymbols, which returns the number of characters in s that are neither letters nor digits. And we have a little note here that says it's to be implemented in part A. So this is the first method we'll be implementing. And right away you can see, okay, we're using numSymbols. We have something to tell if we have numLetters or numDigits. So you can start formulating how you might use what you're given to actually implement what you have to do in part A. Going down, the next one returns the strength of password P as described in part B. So we'll get more information about that when we read part B. And that method is called password strength. And then there's a little note here that says there may be instance variables, constructors, and methods not shown. Okay, so if there's anything you missed there in that first part of the question, you should do a more thorough read through. But if not, let's keep going. So part A says, complete the num symbols method, which finds how many characters in string S are neither letters or digits. Two helper methods, num digits and num letters, have been provided. So that's a good indication that you're probably going to be using them. And if you're not using them, there might have been something that went wrong. So this first note here says num digits returns the number of digits in its string parameter, and num letters returns the number of letters in its string parameters. The following are some examples showing the use of num digits, num letters, and num symbols. So this just gives you some method calls and then shows you what it should output. So it basically just returns what's explained by the descriptions of the methods. So the instructions say, complete the num symbols method below. You must use num digits and num letters appropriately to receive full credit. And so here's a little description of this method again that we're implementing. Returns the number of characters in S that are neither letters nor digits. Okay. And we have a precondition here as well. It says S contains at least one character. So we don't have to handle the case where there's no characters in S. We can just assume it'll have some characters already. And it's supposed to return an int. That's also important. Okay, so what I'm going to do next is I'm actually going to hop into REPL because we are in a virtual classroom right now, and it's the easiest way that I can share my code with you. So I'll see you back here in a sec. Okay, so I've gone ahead and copied in the description of the method we're implementing and the method signature, so we can start coding right away. So first, let's remind ourselves what we're actually implementing here. So we're implementing a method called num symbols that returns an int, and it takes in a string S as a parameter. And what we want to do is return the number of characters in S that are neither letters nor digits. Now your first instinct here might be to loop through the entire string and check each character, and then add it to a count if it's neither a letter or a digit, and then return that count at the end. And that's a good instinctual way of starting out here, but it's not actually the best way of doing it. And remember, we have num letters and num digits that we need to make use of. So instead, we have a string, and we have what we don't want. We can get the count of the letters and the digits, and we want everything that's not a letter or a digit. So instead, what we can do is get the length of the string and subtract off what we don't want. So that's the number of letters and the number of digits. And what we'll be left with is actually what the question is asking for. It's everything that's neither a letter nor a digit. So let's go with that implementation. So we know we need to return something. So I'm going to put a return statement in there so I know or remember that I'm going to need to return something. And I'm going to store my results in a temporary variable called result to start off with. So what I want to start with is the length of S. So if you remember from our course, we want to put the variable that S is stored in, or our string is stored in, dot, and then access our length method and call that. And then we want to subtract off num letters, which takes in a parameter, which is a string, and and subtract off our digits as well, and do the same thing, pass in S. And then to end off the statement, I would add a semicolon. Now, when you're implementing something like this, if you forget how to call num letters or num digits, just go back to the question and look at the method signature. You'll be able to see what kind of parameter it takes in, the name of the method, and therefore how to call it. Okay, so what we're doing here is we're getting the length of our string and subtracting off everything we don't want. And this will give us how many non-letters and non-digits there are. Then we want to return this, so I can just say return results. So this result variable stores our result. So this is one way to do it. Another way we could do it is we could actually copy this whole thing here and return it right away. And then we don't actually need this first line there. And this is another way of implementing this method with one less line of code. So that's our solution for part A. We're going to move on to part B now. Okay, great. So let's move on to part B. And again, what we'll start off with is a read through of the question. So to start off, it says, write the password strength method. The method returns one of 3 string values, strong, medium, or weak, depending on the characters of its string parameter p. And then it gives us some criteria for each type of password. So a strong password is one with at least 8 characters and at least 1 digit, 1 letter, and 1 symbol. A medium password has 2 possibilities. The first one is that it's between 5 and 8 characters, 5 inclusive, and it has at least one of which is a symbol. So at least one of those 5 to 8 characters is a symbol. The other opportunity for a password to be medium is when it has 8 or more characters but is missing a digit or letter or symbol. And then finally, for the weak password, we also have 2 possibilities. The first one is that it's fewer than 5 characters. And the second is that it's between 5 and 8 characters, 5 inclusive, but none of the characters are a symbol. And again, we have some examples. So these examples basically highlight the criteria above. They're basically examples of what our method should do once it's successfully implemented. So what we want to do is complete the password strength method below, and we want to assume that num symbols works as specified, regardless of what you wrote in part A. So that's important because even if you weren't totally sure about part A, you can assume for part B that part A was implemented correctly. So again, we have our description of the method here. And going on to the second page, we just have our method signature. So we can start implementing this right away. But first, let's actually take a note of some of the criteria in here. So because this is not as straightforward of a question as the first one, I probably would do a little bit more planning first. So we know that different things are going to happen based on what we're passed in. And that kind of structure indicates that we're probably going to have a series of if statements that will do something different based on some condition. So what we need to do is figure out what those conditions should be. So now we can jump into REPL and we can start talking about this. So once again, I've copied in the description of the method we're implementing and the method signature, so we can jump right in. So just like we talked about how we're going to probably have a series of if statements, now we have to talk about how we're actually going to split up these if statements. So if statements have different blocks that run based on a certain condition. So what we need to figure out is what those conditions should be. And how we can do that is we can read through this description and figure out what kind of commonalities or cases that emerge. So if you read through these descriptions again, you'll notice that each case or kind of area of behavior depends on first the number of characters in this password string. After we figure out the number of characters, then sometimes we ask another question. For example, in strong password, first we check, does it have at least 8 characters? If it does, then we need to check, okay, well, does it have at least 1 digit, 1 letter, and 1 symbol? And if it does, then we return strong. And the other ones follow the same kind of pattern. For medium, for example, we check, okay, first is it between 5 and 8, 5 inclusive? If it is, does it have at least 1 symbol? And if so, then we can return medium. Now, not all of them follow this criteria. For example, a weak password, the first possibility just checks if it's fewer than 5 characters. And if it is, right away, it knows that it's a weak password and it will return weak. But it still operates first on the number of characters in the password P. So we can think that we can have if statement cases that operate first on the number of characters in the string. And within those if statement blocks, we can then ask any subsequent questions we need to ask. So let's go with that implementation. Now, again, the commonalities we see is that we're commonly going to be operating on the number of characters in the password, the number of digits, number of letters, and number of symbols. So to make my life a little bit easier, I'm actually going to create local variables that store these metrics for me, so I don't have to calculate them every time. So first, I'll create a, just going to make sure I have the right indentation here. So first, I'm going to create a variable called plength that's going to store the length of the password P. Then I'm going to create a variable called digits that's going to store the number of digits, and I can use my numDigits function that's in this class. So again, remember that's provided to us in the question. I'm going to use the other method that's in this class called numLetters. And I'm going to use numSymbols as well. And again, if you forget how to call any of these methods, just take a look back at the question. Okay, so now I have variables that store the length, the digits, the letters, and the symbols in this password string P that's passed in as a parameter. Now I can start partitioning these into if statement blocks based on what we talked about. So the first one I'm going to check for is, does it have at least 8 characters? So for this, I'm going to operate on P length, this variable up here, and I'm going to say, is P length greater than or equal to 8? Now, a common mistake might be to forget this equal sign. But what that means is that when the length is equal to 8, it won't fall into this if statement block, and we want it to. So we can figure out if we need that equals in addition to the greater than by looking at the description. When it has at least 8 characters, so that means 8 inclusive. So again, that means we need that equal sign. So if that's the case, then we want to ask another question. Does it have at least 1 digit, 1 letter, and 1 symbol? So let's check. If it also has digits greater than or equal to 1, and it has letters greater than or equal to 1, and finally, if it has symbols greater than or equal to 1. If all of those is true, then we want to return strong. So that's the first case done. Let's move on to the second case. So the second case is for medium passwords. So it's the first of 2 possibilities. And it says if it's between 5 and 8 characters. So this is a new if statement block. So we want to add that on to the outer if statement sequence here. And we want to check else if P length is greater than or equal to 5, and if P length is less than 8. So this condition here checks to make sure if it's in the range 5 and 8, 5 inclusive. If that's the case, let's go back to our description. We need to check if it has at least 1 symbol. So then we can say if symbols is greater than or equal to 1, then we can return medium. Perfect, and let's move on to our third case. So this one, 8 or more characters, but is missing a digit or letter or symbol. So this one is checking the case where it's 8 or more characters. That's the first question we need to ask. And we actually already have an if statement here that's checking that. So we know we're going to go into this inner block here. And inside this inner block, we're checking if there's digits, letters, and symbols, at least one of them. And that was for this top case here. So let's think for a second. If this evaluates to false, which means this condition evaluates to false, that means that either a digit, a letter, or a symbol was missing. So what we can do here is we can actually just add an else case that returns medium. And this actually takes care of this third case here. Now let's talk about that once more. So first we ask if the length is greater than 8. Then this first condition checks, does it have a digit, a letter, or a symbol? And if it's true, it will go into this block. If it's false, it will go into this block. And if it's false, it means that it's missing either a digit, a letter, or a symbol, which matches this criteria here. And that's why this criteria here is met by this else statement block. Pause the video and rewind if you need a few seconds with that. If not, let's keep going to this first possibility in the weaker category. So in the weaker category, the first one says if it's fewer than 5 characters, then that's it. We can just return weak. Now our outer if statement sequence here is partitioned on the length of the password. So if it's greater than 8 first, and then we check if it's between 5 and 8, then what we can do here is we can just add an else statement. Because if it doesn't fall into all of these other cases, then we know it's below 5 characters. So you could say else if P length is less than 5, or you could just say else. Either one of those works for you. So if it's 5, if it's less than 5, then what we want to do is we want to return weak. And that gets rid of that last case that we were just working on. And finally, we have one more, and this one checks if it's between 5 and 8 characters, 5 inclusive, and then it checks as long as none of them is a symbol. So we already have a case for between 5 and 8, that's right here. And just like the other one, we can actually just add an else case and return weak here. And again, we'll go over why in a second. Okay, so inside of this if statement block, we check first if it's between 5 and 8 characters. If it is, then we check if it has a symbol. And if it does, from one of our previous criteria, we determined that it was supposed to be medium. Now, if it doesn't have a symbol, then it matches with this criteria, between 5 and 8, but doesn't have a symbol. So we can just add an else block and then return weak. And now what we have here is a completed function definition for password strength that matches with our description. So this one's definitely a longer one, but congrats, you're done. So now we will move on to question 2. So pause the video if you need some more time with this question. Actually, before we move on to question 2, we're going to go through the scoring rubric for question 1. Now remember, there's multiple ways to answer a question, and as long as you produce the right functionality and follow any instructions in the question, you can be sure to get full marks. So in this case, for part A, the first point says to use s.length, and we did that in our implementation, so that's a check. Then we need to subtract off num digits and num letters. Now in this case, they surrounded it with parentheses, so we could have subtracted off this whole block, or you could subtract off each one individually, which we did, which also works, so that's a check mark. Moving down to part B, test length is greater than 5. We did that in our else case. Test length is between 5 and 8. We also did that. Test num symbols is greater than 0. So we didn't say greater than 0. We said greater than or equal to 1, which is essentially the same as greater than 0. So that's also a check mark. Else return weak. We did have that part. Test for digit, letter, and symbol in long password, which we also tested for. Return strong and return medium. So again, we followed all of these check marks here, and this is the kind of rubric you can expect that the markers will use on the AP exam. And we'll go through again the rubric for part 2 after we've completed it. Okay, so let's start question 2. Just like for part 1A and part 1B, we're going to do a complete read through of part 2 before we actually start. So let's go ahead. In this question, you will write the implementation of a Snowy Owl class based on the hierarchy of classes shown below. And right here, we have a little class hierarchy diagram. So we can see bird at the top, and it's extended by a class called owl. And we know that because it has this open arrow pointing up towards bird. Now what that means is it's defining a superclass-subclass relationship here. So that's something that's important to take note of, because that means that an owl is a bird, so it follows that is a relationship, and that means it inherits everything from the bird class. The same thing happens here with Snowy Owl. Snowy Owl is a subclass of the owl class, which is the superclass, and Snowy Owl extends or inherits from owl. So this hierarchy is really important to how we're going to implement our Snowy Owl class. And then it gives us some implementation of the owl class. So the owl class is as follows. We have our class declaration. It has a private instance variable called name that's of type string. We have a constructor here that initializes name to be an empty string. And then we have another constructor with parameters, which initializes name to be the parameter that's passed in. And then we have a method called getName, so a getter. And all that does is it returns our private instance variable name. And then we have a method called getFood, which returns a string, and it returns furry animals, insects, or small birds. So it seems to be what an owl should eat. Now we have some features of a Snowy Owl. So a Snowy Owl is an owl whose name is always Snowy Owl. If the owl is a male, the color is white. If it's a female, its color is speckled. So we can see here, this is probably identifying some behavior we're going to have to implement in our class. Finally, it says, food for a Snowy Owl depends on what is available. A Snowy Owl will randomly eat a hare, a lemming, or a small bird, where each type of food is equally likely. And finally, the Snowy Owl class should have a private instance variable of type Boolean that stores true if the owl is male or false otherwise. It should also have a constructor and a getColor method that returns a string with the Snowy Owl's color. Write the complete Snowy Owl class below. Your implementation should meet all specifications of Snowy Owl. So it gives you quite a bit of information about what should be in here. First of all, again, because we saw that UML diagram, that hierarchy diagram, we know that a Snowy Owl is going to inherit everything from an owl. And then in addition to that, it's going to have a variable that stores the gender, And it's also going to have a getColor method. Now, some other things you should have noted from these features here is that there's 2 points, the first and the last point, that indicate we're going to have some overriding. So not so much the constructor, and we'll talk about that when we actually do our implementation, but more the food. So right now an owl has this method called getFood. And what it does is it returns what an owl should eat. Now this specification here tells us that a snowy owl will eat something different. Now we already inherit the getFood method from owl. So this indicates we're going to have to override that method and give it some new implementation for our snowy owl. Okay, so let's jump into REPL again and we'll get started with this question. Okay, so we're going to be implementing the snowy owl class now inside of this file, and I've copied in some of the key points from the description so we don't have to keep flipping back and forth from the problem. So first of all, let's start with creating our class. So to create a class, we need to declare a class with public class and then the name of the class. So in our case, it's called Snowy Owl. Now we could do this, but I just forgot something there. So pause the video for a second and see if you can figure out what I forgot. Okay, I hope you paused. Let's go back to the question. So Snowy Owl inherits from the owl class. So that is creating an extends or is our relationship. So we need to include that in our class. So what we're going to say is public class Snowy Owl extends owl. And so that is our class declaration there. Now what we're going to do is let's go through the points and create our method signatures. And once we have everything, then I'm going to fill them in. So the first point says Snowy Owl should have a private instance variable of type Boolean that stores true if the owl is male and false otherwise. So first let's create our private instance variable. So private instance variable, which we know is of type Boolean, which is going to be true if it's male and false otherwise. So I'm going to call it isMale. The next one says the name should always be Snowy Owl, so we'll handle that later. The next one said it should also have a constructor and a getColor method that returns a string with the snowy owl's color. So let's create signatures for those. So the constructor is always just the name of the class, so Snowy Owl. For now, we're not going to let it include everything. Once we start filling these in, then we might change that. The next one is a getColor method. And it returns a string, so we want to add that in. And again, we won't actually provide the implementation yet. The next one says if the owl is male, its color is white. If it's female, the color is speckled. So that, again, is implementation. We won't worry about that quite yet. The next one says food for a snowy owl depends on what is available. A snowy owl will randomly eat a hare, a lemming, or a small bird where each type of food is equally likely. Okay, so let's remember that when we extended from owl, we inherited everything inside of the owl class. And what that means is we inherited this method called getFood. So we need to re-implement that inside of our Snowy Owl class. So what we're going to do is we're going to re-implement it. And it's going to return a string, which will be the food that it's going to eat. And we'll call it getFood. And this is going to actually override what we inherited from owl. Okay, so now we have everything that we need for our class, and now we can actually start implementing them. Okay, so what we're going to do here is we're going to keep going through these points at the top to help us implement these methods. I'm actually going to delete the first one because we've already handled that. It has to do with the private instance variable. And we'll start with this one here. So this one says the name is always Snowy Owl. And we know from our superclass owl that the constructor initializes the name variable. We have one without parameters, which initializes it to an empty string, and one with parameters that initializes it to whatever is passed in. So we can actually use the superclass's constructor to get the behavior that we want. Now, to make a call to the superclass's constructor, we use the keyword super. So I'm going to say super, and then I'm going to pass in the parameter I want. So in our case, we want Snowy Owl. And what this will do is it will call the constructor from the superclass with parameters and pass in this parameter and create that behavior. Now remember, the Snowy Owl class inherited the name variable from our owl superclass. And so this will initialize it. Okay, now we also have a variable here called isMale. And isMale should also be initialized in our constructor. So this subclass constructor should also take in a parameter that's going to be a Boolean called gender. Let's call it gender. And what we're going to do is we're also going to initialize this. So we're going to say isMale is equal to gender. So that's whatever is passed in at the time. Okay, so this handles this one. Let's go with this next point here. So this one says it should also have a constructor, which we have, and it will have a getColor method that returns a string with the owl's color. So let's do that next. So getColor is right here, it returns a string. So let's delete that now. Now the next points will help us implement this. So it says if the owl is male, its color is white. If it's female, it's speckled. So our variable isMale handles if something is true or false, so true for male and false for female. So what we can do is we can use that to calculate what our color should be. So if isMale is true, then what we want to do is we want to return white. And if it's false, or in the else case, what we can do is we can return speckled. Now note how I didn't here say isMale is equal to true, because isMale is going to evaluate to either true or false. We don't need to actually check if it's equal to true. It's either true or false, which will make this condition evaluate to either true or false. So that's our getColor method now implemented. So I'm going to delete these next two points. Okay, so now the last one for getFood. Let's read this point here. It says food for a snowy owl depends on what is available. A snowy owl will randomly eat a hare, a lemming, or a small bird, where each type of food is equally likely. Now a keyword here is randomly. That means that we need to randomly pick something. We need to randomly pick between 3 different options. Now from our coursework, we know how to generate a random number. And if we can generate one of 3 possible numbers, we can use that number to pick which food our snowy owl will eat. So that's what we're going to do. We're going to generate 3 possible random numbers, one number out of 3 possible options, and then depending on what number that is, we'll output a food. So let's try that now. So we're going to say int random num, and I'm going to use my math.random function, which will generate a random number. And I want 3 possible options. And remember, this is going to give me a decimal value. So in order to get an integer value, I have to cast this down to an int. So that's what I'll do there. So now I have a random number, and I can use that now to pick which food I want. So let's say if random num is equal to 0, then what I want to do is I want to return hare. And then let's do else if random num is equal to 1, I will return lemming. And then in the else case, which means that it's equal to 2, what I'll do is I will return a small bird. Whoops. Return small bird. Okay, so this handles our random functionality. And that gets rid of our last point. And this here is our completed implementation for Snowy Owl. All right, congratulations. This concludes this AP Computer Science exam tutorial. I hope you were able to follow along and this was helpful and you gained some skills and tips on how to best tackle the free response section of the exam. Keep a lookout for our other tutorials and good luck with your